Now, in a 30, 60, 90, we have a slightly different situation. We are going to refer to the short leg. The shorter leg of the triangle is always between the 60 and the 90. So we're going to call that X. So the short side is always going to be our reference point. The hypotenuse, now some of you guys are trying to get to this point. What did you notice about the hypotenuse in the 30, 60, 90? Yeah, it's twice the length. And what did you notice about the longer leg?
X radical 3.
No. Say that again, Justin. X radical 3. Alright, now, I'm not much of a person to sit there and do mnemonics. That's really, I just learned to make sure that you know what they are. I really don't do like little thinking games, memorization games. You just gotta know it. So just know it. But I will help you guys out here a little bit. A lot of students tend to mess up which one has the radical 3, which one has the radical 2. It's really simple. 30, 60, 90. 3, 6, 9 has the root 3. Okay? 45, 45, 90 has the root 2 because you have two angles that are the same. Alright, so an easy way to remember that. And also, some students on 30, 60, 90 forget which side has the root 3. Well, where's your 30 at? It's on the bottom, alright? It's right there. So the root 3 is adjacent to the 30-degree angle. So here we go. Take a look at number 5. Bryce, what's my hypotenuse on number 5? Very good. Shannon, what's the longer leg? So what's the length of our bottom side right here? Well, that's the general format, but what's our X value? See, it's 3. Right, 3. So whatever that length is, Shannon, that becomes that times root 3. All right, Shay, take a look at number 6. The 9 root 3 represents which? Is it the long leg, short leg, or hypotenuse?
Long leg.
It's the longer leg. So then what's my short leg? Short leg would be 9. Right? Because the longer leg is the short side times root 3. So ask yourself, what's being multiplied by root 3? 9. So therefore, that's the length of the shorter side. Okay, so Destiny, what's my hypotenuse? Say again? Should be 18, right? Okay. Remember, the hypotenuse is twice the short side. Okay. Number 7.
Ooh, that's a tricky one. No, it's not.
What are you given on number 7? You're given the hypotenuse. How do I go from the hypotenuse to the short side? I divide by 2. So, keeping it as a fraction.
5
No, 11 halves. So now, guys, to make this really simple, what's the longer leg?
11 over 2
And what we normally do with that, Justin, is put the root 3 on top. So 11 root 3 over 2. Okay, now number 8 is a little tricky. What are we given on number 8? We're given the longer leg. Where's the root 3?
It's not there.
It is there, but it's somewhere inside 12. Okay, so if we call this X, we know that the longer leg is X times radical 3. So how do you solve for x?
Divide
Divide by root 3. And therefore x is 12 radical 3 over 3. And guys, that's a technique we've learned before in this class. Okay, so that should not surprise you guys where those numbers come from. Okay, can that be simplified?
Yeah, for doing what?
How many times?
4 times.
4 radical 3. So our short leg is 4 root 3. What does that make the hypotenuse? If my short side is 4 radical 3, what would that make my hypotenuse? 8 radical 3. You don't double the square root, you just double the coefficient. Okay. Now, one thing I do want to talk to you guys about here is really when do you use these? And I think sometimes you guys need to open your minds a little more and say, okay, yeah, I understand that the math is there. I might not always be the one to use this, but I do understand there is a use for it, and somebody else might need to. And who knows, there might be a point in time when I need to use this in my life. I told you guys before, I'm in the process of actually building my own bag toss game. Yep.
Still are.
Almost done with it.
What is it called?
Wait, what are you
For toss to the bag.
And in regulation, it's supposed to be at a 30-degree incline. And the problem I had was, what length do I need to cut the legs? Because oh wow, that's fine. If this is supposed to be at a 30-degree angle, and understanding that's approximately a right angle, what triangle did I just create underneath that board game? 30, 60, 90. Well, the problem is that height needs to be approximately a foot. So, this is what's really interesting then. If I actually have a 30, 60, 90 here, what kind of triangle do I have here?
45.
No, that's actually another 30, 60, 90. Okay. So, my question was, if this needs to be 12 inches on the longer side on a 30, 60, 90 triangle, then what's the length of the hypotenuse that I need to cut for my brace? So that was actually kind of the hard part to come up with. And you're right on. What did it end up being? 8 radical 3. So then I had to figure out, okay, what's the approximation of that in terms of inches? And then that told me how long to cut my feet. So again, it's not something like you're going to use every single day. I don't expect you guys walking out of this classroom tomorrow knowing how to use 30, 60, 90. Well, okay, I do expect that you know how to. But I don't expect that you're going to. But it's in these weird situations where you would never think that you're going to need to use that. But you really do. I know you would have. Can't imagine how many cuts you would have made. No, that wouldn't work. Do a little bit longer. Nope, too long. Nope, a little shorter. Nope. So, anyways, I just want to kind of show that to you guys that this is something that, you know, I thought as I was making this, it's like, I didn't think I'd ever have to do that. Yeah. It's all there. It's amazing how much you guys use in building trades. I talked to Mr. Sutton about it. He's like, no, you just do it. That's